Mr. Leif Granholm from Trimble, the grand old man of BIM and information management for many, many years. So welcome, Leif. Stage is yours.
Okay, thank you. Okay, it's a pleasure also for me to talk here, and thank you to the organizing committee that I get to speak here of a topic which is very close to my heart and which I'm very enthusiastic about, which is open standards. First, a few words about the topic, so I say role of open standards, because I think still people talk about open BIM, but the actual role of open standards is still, in my opinion, quite unclear in the general BIM market. And then we have another thing, BIM, or model-based information, as I call it. When I talk about model-based information, what I mean is information that has been modeled based on reality, on the terms of digital processing from the start. So the traditional way of making and designing IT systems have been that you look at the human readable documents, papers, how things have been done on paper, and then you have digitalized those. But no, that's not how you should do it, and that's not how we have done it in old Tekla and Trimble. So we go directly to the reality. We look what's there, what needs to be done, what do we need to store, what do we need to process, what do we need to do with it, and then we do the information modeling straight on the digital processing terms, not kind of via this human processing with pictures and drawings and schemas and tables. So that's simply what I mean to model. But that's a very important thing, because it makes a big difference whether you try to digitalize the traditional paper process or whether you start from the actual physical things and digitalize those. You can leave out much of things which you have done unnecessarily in the paper world and do new and other things which are possible in the digital world but which were not possible in the paper world. So first, a few words about myself. I have been now working 44 years with Tekla and Trimble, and during my career I have done every job there is to do in the software industry, so I'm a software guy in and out, truly. And I'm pretty unique in that I have done about 20 years on the geospatial side, GIS systems for city municipalities, for energy companies and other that kind of things, and then about 20 years with BIM, straight off BIM. And now the last 10 years I have focused on open standards, advocating and promoting the use of open standards both within Trimble and in the general market, and also participating strongly in development of standards. So I worked with Building Smart. I also have worked for a long time with OGC and ISO and CEN. So I have the last period of my career I have been very dedicated to open standards, and well, you know that after my presentation that I'm a big believer in open standards and their usefulness in general and why they are needed. So as I'm a BIM ambassador, I get to define to you what is my definition of BIM, and that's very simple actually. I believe in simple is beautiful. So for me, BIM is just the transition from human readable documents, which you always needed a human to interpret, perceive, process and do things to machine readable data which you can process automatically. So one of my definitions of BIM is automating the reception of data. So I'm going to elaborate this a bit more in the presentation. But this has some pretty big implications and big changes for the whole industry. So in this human readable document world, the presentation and the content were 100% bundled. So you couldn't debundle it, because the presentation was decided by the one who created the information, and the only way the information was kind of published was with this single presentation which was there in the document. Not so in the digital and model-based world. Here they are debundled. So you get the data in a machine-readable form, which is not readable by humans directly. But instead you always have to use some software to present the information in some way to you. And this is a big change, because now the presentation was previously decided and controlled by the creator. Now it's decided and controlled by the consumer, totally. So the producer of information cannot control how the consumer of information consumes it. And there are plenty of options. And I'm coming to that because I'm from the software industry. So, of course, there is an interest for software industry in this. And coming to this, so the BIM industry has been very much focused on creating data so far. And the way to publish data has mostly been in form of drawings. So the modeling, electronic modeling, have been used mostly just to create the human readable documents. But that's changing about now. We are living in the midst of that change and transformation, that we also start to publish and share the machine-readable data, i.e. models of different things. And that's going to give a huge opportunity for software making, because today 80% of software is for production, 20% for consumption. And that will change. 80% will be for consumption, because everybody in a project consumes data. And also during the life cycle of the facility we are building. But this is on top of that, the production continues to grow. So the huge growth, the exponential growth, will be on the consumption side. And I'm coming to that also later on, that this will be mostly based on CDEs, this new explosion. Then a few words about information management. The kind of original idea of BIM and also original idea of IFC is that it's a database schema. That we have the first presentations of IFC, and I heard in Building Smart back in 2004, where that this is a database which you populate with data. And they said, back then already, no, that's not going to happen in the foreseeable future, that we would have one single database that everybody would share and everybody would own, and we would somehow magically manage the rights and the scopes and who has the right to do, who is responsible for what aspects, and I'm coming to that a bit more. And this is now starting to be clear to everybody that this is not going to happen. But there really is no generally accepted concept on what then, if this is not possible. And this is the kind of very vague UK BIM level 3, which they talked about, which was because it's not possible to kind of make it real, so it was never made real, so it has faded away. Hardly anybody talks about BIM level 3 anymore, because with that idea, it's not possible, it's not going to happen. And so I have been pushing and putting forward different idea and different concept on how to do this. And do it so that it avoids the problems of this totally shared information, but still delivers on the BIM promise that you don't have to re-enter and re-enter and re-enter the same information again and again in different systems, which has been the kind of, you have all seen this curve, that information amount of information goes up, then it comes down, goes up, comes down. But this concept I'm presenting will avoid that almost completely, not completely, but to a large extent will avoid this problem. And I call it productivity BIM. So if you now go and ask people out in the market and in general, why? I'm a curious person. I'm very curious and want to know why and the reasons and purposes. And if you go and ask people, why do you do BIM? What do you think most of the people will answer? I'm pretty sure that today most of the people answer collaboration. We want to collaborate with others. We want to work together. We want to share the information. But I'm saying that that's not maybe the right way to tackle it, because that has led to that BIM has, if we take the high-rise construction, not infra, because infra is still new in BIM, so this phenomena hasn't come to infra yet, but in the kind of construction industry, many people are experiencing BIM as a burden. Because they don't do it for themselves. They mostly do it for other people. And that's why I'm proposing and pushing that the main reason to do BIM, the purpose, why do you do this digital modeling and digital models and digital processing? You should do that to be more efficient yourself, for your own selfish purpose. And this collaboration aspect should come more as, you could say, collateral damage or a byproduct of yourself. You publish what you have modeled. You model your own added value to the project, and you publish that for others to use in the extent they can use it. And I'm coming in a while more about this, how you do it. And Tekla Structures is a good example that this works. Because one of the implications and follow-ups of this is that when you do it for your own operation, you are using that data primarily for your own operations, the data quality is good. And that's why Tekla Structures models have a reputation of being of good quality, is because they are made for selfish purposes, almost always. Very seldom do you create a Tekla Structures model just for collaboration. You do it for your own purposes, what you need to do the actual design or whatever you are doing, added value, you create that in Tekla Structures. And that's a pretty important thing in BIM, that the models are of good quality. If they are bad quality, they are more hindrance and negative than positive. Then a few words more about this modeling in general. So typically today, the reality is far too complex to put in one model, in a single model. So that's, if somebody says that we have one or single or all or something, I go, no, we don't. We can say that we have, but we don't. So, and a model is also always based on an abstraction of reality, because we can't model the reality. We have to start from string theory and particle physics, which is a hobby of mine, by the way, to model it upwards from there if you want to model the reality completely. And that's totally and completely impossible with current level of current and foreseeable technology. And a very important aspect of an abstraction is it's for a purpose. You don't have an abstraction that's for all possible purposes. You simplify typically something in an abstraction to be more useful in some specific purpose or use. So elaborating a bit on that more, no such thing as the model. So different viewpoints and use cases, they require different representations of the reality, of the same physical phenomena to do different things. And I classify coarsely object types used in BIM in these four main categories. So we have functional objects, which mostly represents how the building looks, how it works, how it serves its users, how do you use the building. That's the main purpose of this functional object representation. Then you have physical objects. Well, that's clear. How do you build the thing? That's why you need the physical objects to, when you want to plan exactly, design how you are going to build it. But then a bit more obscure logical objects, also called constraints, that you might say that between two these walls, whatever you do, there has to be a straight angle. And there is a kind of endless amount of these kinds of constraint objects. And then you have a final group, which is abstract objects, with the space object is the best example, and space is by far the most useful and most used object in BIM, because the facilities are usually they are existing to provide spaces. And that's what you want to design, manage, operate, and do things over time. Then you also have data describing the process and other things in BIM today. A bit more about that. Typically, an architect represents a slab as one object, for the engineer 5 objects, for the detailer 10,000 objects. Though it's clearly the architect can't do with a detail model what is his job, making big changes, and the detailer can't do his job with a single slab. So we need totally different representations of the same thing. This is another aspect of that. You can see that this is not my slide. This is an architect's slide, Greg Schleusner from HOK, and he's my successor as the chairman of the technical room in Building Smart, and I have been kind of pushing these ideas to him for 10 years, and he's catching on with this. And this is an important thing also, that in a construction project, you take almost any objects, and you have several owners of different aspects of that thing. You have fire protection, you have chemical composition, you have many things which are typically the responsibility is at different parties, different contractual parties in the project, and we need to manage. And even with the same owner, you need different representations. Net space, gross space, volume, other things. So it's not at all simple. And one kind of general technology to solve this and deal with this is called entity component systems. It comes from the game industry, and this is now being looked as some kind of guideline for development of next generation of IFC to kind of cater for this aspect of different representations and different ownership of different aspects and representations. But as a kind of simple solution, which you can also already do with current IFC, I'm proposing this federation and publishing-based information architecture. And that means that you separate the data which you create and you own and which you get from others. That you never mix them. You don't, and you even keep them in different schemas. So the data you get from others as IFC, you keep as IFC. You don't convert it, bulk convert it to the native schema of the system you have, because that native schema should be kind of optimized for the task you are doing. What is your task? What is your representation of the objects in the building? And that's not because IFC is kind of the common denominator, so it can't be as deep for every specific purpose and use case as your native is. And it also doesn't have the intelligence to how to react to changes. And because that's mostly just functionality and code, not data. Then you publish, when you create your objects which you own, this makes that the information management aspect is the same here as it is with drawings. You have data which you publish for others to use then continuously. And for that, the software needs to develop also, because currently software is mostly user-driven, so it's very much clickety here and there, and that needs to change so that the software becomes more data-driven, so that it can take the data from other parties, from previous phases, and use that and create your added value based on the data that was done earlier. And Technostructures is already following this. And to do this in practice, we need something which I call the multi-kernel software architecture, and that's just in brief, so that you have a software code which can deal with data in several schemas on the same time, and merge and combine and join those schemas on the fly based on your use case, not a kind of static combination of the different representations. You always do that combination of the representations to help you do your task. You do that on the fly in your application. And as a schema, it looks like this, that you have an application layer, you have your native data storage, and then you have something called standard data abstractions and direct access. These standard data abstractions, Trimble customers know that this is TrimBIM, which we use for this. Then if we look a bit more on the workflow, so the idea is that you take as input, like the architect's lab, you have your application has functionality to take the slab as input, not you're going click, 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 and do the engineering work as automatically as possible. At least help you by kind of full automatic, semi-automatic, or full manual. You can have all of those options. And the interesting thing here is that you can, on the same time, create links, because today in the project all of this happens in parallel, and you need to keep all of these representations up to date throughout the project. And so to have these links implemented with linked data technology, you can propagate changes downstream and change requirements upstream, because the engineer can't go and change the architect's model, no way. That's not going to happen, at least in the current state of the construction industry. So what does the engineer do? Well, he asks for a change from the architect who manages the kind of general dimensions of that slab. And BCF was, by the way, created to do this. So with BCF, you can send semantic change requests. You don't say that raise the ceiling, or lower the ceiling, or raise the roof. You say, I need more space. So that's kind of a semantic change request. And we have implemented this in Finland already on the MEP side with void reservations for MEP equipment in the structure. So this concept is already working. And as an application schema, it looks like this, that you have your native model and your native object is linked to this incoming IFC objects, and when you export it again for somebody else to use, it's linked to this. And this works both in the design phase, construction phase, and operations phase, because that's just a category of software which is still totally missing, is this model-based facility management and facility operating system. Also, the native data storage is changing quite quickly. It's becoming more. We had a great presentation of the Kruunuvuori bridges about how this is used now, that you have there less and less static data, more and more methods and algorithms and dynamics, and with these visual programming systems like Grasshopper, you can the end user can himself create a very intelligent model. But those intelligence models are hard to consume, so that you will consume as snapshots in IFC. And the system architecture would look like this. So my prediction is that the bulk of the new software is coming built on top of these common data environments. And that leads to that the competition between the BIM vendors is going to be between these interfaces, between the CDE and the new, and I want to call them platforms, more than just data environments, because there is a new generation of applications being built on top of those. A part of that interface will be standard, but not the whole. And because of that, in any major projects, most of these major platforms will be in use, which means that these need to communicate between themselves, the platforms as well, and that's underway standards-wise. Building Smart is, as we speak, developing this OpenCDE standard to enable this, both to enable some generic functionality of clients to the CDE, but also this cooperation between the CDEs. And the software directions I talked about earlier, that we need to go to this data-driven direction, and it's clearly happening. And my vision and mission, and why I'm still working with this my passion, you could see that I want to leverage the role of open standards, so that open standards like IFC, GML, and others would be the normal way, would be the routine way to consume information. That wouldn't be just some small hop from system to system. That would be the normal way, because then we have a total separation, so that you can have anything producing data and anything consuming data, and the data will flow between those when we have the consumption is done using open standards. And that's the reason I really believe in open standards, because that makes a market, and that makes market economy. That doesn't allow for monopolies. That opens the scene for new startups, new small vendors. They are more or less on the same plane than everybody else that doing this. And I am a big believer in market economy. True market economy, we have true competition and not monopolies. And I see open standards as the biggest biggest enabler of having a true market economy in the BIM world. We have done quite a lot of research over the years for this, together with Aalto University and funded by old Tekes and Business Finland or whatever it's called nowadays, and we have got millions. And for instance, IFC OWL has to a large extent been developed on funding from these DRUM projects, where we looked at this, looked at going to more cloud-driven, web-based, and new semantic web, open the linked data technologies to drive this. So we also have a technology shift from the traditional database and modeling tools and data sharing tools to the next new generation of more flexible data. That was my presentation. Thank you.
So, thank you, Leif. It was a very interesting presentation. There is one question in the message wall. So how do you see that? Would it be kind of more efficient to educate and enforce better guidelines instead of on going in the software development direction?
Didn't quite get the question now.
You can read it here.
BIM not to be, BIM not to be a burden. For better guidelines. Well, I would say that we need both.
Okay, so short answer.
I don't. I can't see that we should emphasize one or the other more. We need good guidelines and good instruction, ways of working, but we also need the software development because without software, nothing happens in BIM.
Good. Any more questions from the audience? Do we need term BIM anymore? What's your opinion?
Well, if with my definition, definitely yes. And this is ongoing on every aspect or every area of society in a big time, barring one. I make this quiz quite often. Anybody guess which big area of society is not doing much when it comes to creating machine-readable and digital model data? That's happening in all. Medical, you take whatever, industrial, society, infrastructure. Now, that's illegal. The lawyers want it to be human-readable, or not even human-readable. They want everything to be lawyer-readable only. But this is happening in every aspect that data is being modeled, digitally modeled.
Yeah, and then there is one more question, that this is a real paradigm shift. To your opinion, do these developments also require another look on requirements and open standards? Yes, because still a big deal of the thinking and the open standard it sticks like something sticking, this single database idea. So that's something I try to get rid of, that we need to be able to think more in terms of data flow than just storing everything in one place. Good. More questions from the audience? Oh, still coming. So how would the integration with design and analysis software be done? Through IFC as well? And what about the calculation results? What's your opinion?
Yes, through IFC. We are working on that. But that's not ready in IFC at the moment. It needs still. And that's one thing that IFC needs is better modularization, because as one package now it's far too big already and getting bigger.
Okay.
That was one.
Okay, there is one question. Can we get microphone there?
Thank you for presentation. My question regarding, you mentioned open CDE requirements. At which stage this document is?
Open CDE standards.
Standards, yes. Yeah. Because currently it's a huge problem to make, for example, Trimble connect to talk with ProjectWise. How do you see this collaboration might happen in future? So the software vendors will have to collaborate together to follow those requirements.
I see that requirement coming very much, that the CDEs, because of this, the things I mentioned, they will have to be able to cooperate, the CD, different vendors' CDEs. And that's going to happen, and that OpenCDE standardization work, it's concrete work which is ongoing at the moment. So that's going to be the solution for that.
And when do you think this requirement will be in power?
Sorry?
When it's going to be issued, this requirement, when we're going to be able to
standard?
use it? Yes, standard.
It will take 1 or 2 years at least still. It's quite early in the works at the moment.
Thank you.
Okay. So thank you, Leif, for your presentation.
Okay, thank you.
And very many questions.
Thank you.